So let me illustrate how we have gone around to building a portable, secure, and compliant cloud platform using Kubernetes. First of all, for those that are unfamiliar, but also for those that are familiar, let me remind you what is Kubernetes and what is the power and the value of Kubernetes. Well, first of all, it is a production-grade container orchestration engine. So it's what you would generally want to use in case you want to run a containerized application on several servers or VMs. Now, the reason why Kubernetes has kind of become the dominant solution for container orchestration is because it's community-driven and open source. And this is very important because not only that it's open source so that the source code is available, but its governance is also rather neutral. So the project itself is owned by the Cloud Native Computing Foundation, which has plenty of members, and I very much encourage you to join as one of the Cloud Native Computing Foundation's members. And the Cloud Native Computing Foundation is instead owned, is part of the Linux Foundation. So no single vendor can push their interest against the interest of other vendors. And the beauty of Kubernetes is also that while it is a laser-focused project, it is also very extensible. So it has attracted a very rich ecosystem of extensions that I'm going to highlight in the next presentation. And many of these extensions are also community-driven and open source. So basically by adopting Kubernetes and its ecosystem, not only that you get a battle-tested solution, but you also make sure that you're not getting trapped into vendor lock-in. And this is pretty much what we have been building on. So now, since Kubernetes is not that useful by itself, you're generally having something like a Kubernetes distribution, which is Kubernetes plus carefully configured extensions in order to make to derive more value out of it. This is pretty similar to how the Linux kernel itself is not very useful. You cannot do a lot with it. But then if you package the Linux kernel together with other tools and other command line tools, operating system libraries, and maybe even a UI, then it becomes a Linux distribution such as Ubuntu, which is extremely useful to many. So this is pretty much how you should also think about Kubernetes distribution. And we were so passionate about the idea of Kubernetes distributions that, in fact, we went out and built our own, which is specialized for dealing with security and compliance issues around data protection regulations such as GDPR or national healthcare regulations. And we made sure that it comes out of the box with security best practices. We have drawn from here inspiration, not only from the European Data Protection Board, but also the NSA, the US National Security Agency, has recently issued a report on how they think it's best to secure containerized workloads. And we have taken these regulations and best practices and mapped them to ISO 27000 controls, since that is a popular framework to reason about data security and data protection in Europe. And we made it an open source project. And what pretty much we did is that for each of the ISO 27000 controls, we came out with a Cloud Native Computing Foundation project and best practice configurations in order to handle that control to a satisfactory point. And in essence, compliant Kubernetes allows you to run any containerized application on any cloud in a secure and compliant manner. And when we built this last year, the reaction was like, well, this is really cool. This is really great. You're onto something, people. But in order for me to port my application on any cloud provider, I need more than that. I need additional services. At the very least, I need something like a primary database. I need something like an in-memory low latency key value cache. This is useful either to offload the primary database or to store session information. And I often also need something like a message queue in order to decouple my foreground jobs, so those that are, let's say, API handling code, from my background jobs, those that run asynchronous in the background. Okay, so that's great. We're onto something. So then we went back to the drawing board and we thought about, okay, so how can we satisfy these needs? How can we make sure that we run these additional services that applications desperately need to run on any cloud infrastructure? And we pretty much realized that we have two options. Either we build a provider-specific support for each of these additional services, and that pretty much boils down to creating this big ball of mud, the proprietary control plane that I talked about, but yeah, maybe in an open source fashion. Or the second option, we realized that actually we can build on all of these additional services on top of compliant Kubernetes. And this has the advantage that it abstracts away the infrastructure as enabled by compliant Kubernetes. And it also allows us to reuse all of the goodies that are coming in compliant Kubernetes, such as capacity management, logging, metrics, and so on. And so, of course, being very passionate about Kubernetes distributions, we went for the second option. And we realized actually that this decision makes perfect sense and that Kubernetes is a really great engine for a portable cloud platform. So, for example, you can deal with capacity management requirements via resource requests and limits. So you can, so Kubernetes not only tracks how much capacity is available on each of the worker nodes, but you can also say how many CPUs and how much memory each of your containers requires, and then Kubernetes makes sure that they are being scheduled accordingly. And then you can also look at the metrics that Kubernetes exports in order to make sure that you have enough capacity or perhaps even reserve capacity in your cluster in case of a failover. Kubernetes also allows you to do some fine-tuned scheduling via a mechanism which is called taints and tolerations. So you're essentially tainting some nodes with a certain label, and then that will pretty much discourage most of the containers for being scheduled on that particular node. And then if you want nodes to be scheduled on that, if you want pods to be scheduled on that particular node, then you say that it tolerates those particular taints. And combined with some scheduling affinity, you can basically come up with some complicated rules, such as run the database containers on nodes with SSDs, but make sure that other containers do not run on those particular nodes. Kubernetes also offers you an in-cluster private network. So this is pretty much the equivalent of a virtual private cloud in big cloud providers. And this is something really practical if your next cloud provider doesn't offer it. And it pretty much comes with all of the goodies that you're used to from a VPC. So you have a firewall, you have internal load balancer, and you have even a private DNS in order to make sure that your application components can discover each other and can talk to each other without having to, hardcore IP addresses or whatnot. Now, Kubernetes also offers under the hood a strongly considered distributed key value store. You usually don't have access directly to it, but rather are accessing it via a mechanism called Kubernetes custom resource definitions that I'm going to talk about soon. But in essence, this is a very useful mechanism for implementing things such as leader elections, such as failover of the primary. You can also store in this key value store configuration and make sure that configuration is synchronized across replicas of a certain service and so on. And then it also simplifies a lot metrics collection and metrics-based alerting via a project called Prometheus. And similarly, it also simplifies a lot log collection and log-based alerting. We like to use the project called OpenSearch, which is, let's say, the follow-up project from Elasticsearch, but with a more permissive Apache 2 license. So in the end, what you're obtaining is pretty much compliant Kubernetes being what I like to call it the hourglass waist of your platform. Let me illustrate this metaphor with something else. Think about how HTTP acts like the hourglass waist of the internet. Below HTTP, you have various messy, wireless, and wired and mobile networking technologies that all are kind of the same, but all look very different. And they offer different performance. They work slightly differently. Some of them work with MAC addresses, some of them don't, and so on. And then on top of HTTP, you can have then a plethora of different services such as gaming, chat, video and audio conferences, streaming services, and so on. And basically HTTP acts a bit like the hourglass waist. So instead of having to, now I'm saying something pretty absurd that one could not imagine, but imagine just having to implement your video conferencing software for wired, wireless, and mobile technologies. That would be just insane. So instead you're implementing those on top of HTTP, and that then abstracts away the messy network technologies below. And that's pretty much what compliant Kubernetes also does for you. So below it, you have any kind of complex infrastructure, and you have to deal with things such as outbound traffic via NAT and how to make sure that inbound traffic comes redundantly in via something like load balancers or something via BGP Anycast and so on. But once you have configured compliant Kubernetes, then above you can run not only any platform service, such as a key value cache, database, and message queue, but you can also host your application. And judging by Conway's law, so this is law that says that the system that you're designing is very likely going to also match the skills that you're having in the communication patterns that you're having inside your organization. This also creates a very nice demarcation between the various people that you're likely going to have in your organization. So then you can say that, okay, a compliant Kubernetes administrator is responsible up to a certain point in your tech stack. Then you will need some kind of service-specific administrator that only needs to know enough about the platform services. And then you can focus on your application building on top of these platform services. And this kind of extensibility and power is enabled by something that's called the operating pattern. So essentially, Kubernetes allows you to define custom resource definitions, which are a way to extend the Kubernetes API with new objects that are not natively supported or not built into Kubernetes. Then you can define a service-specific operator, which pretty much abstracts away the boring and the tedious parts of setting up a database cluster or setting up a message queue cluster and things like that. And in that case, you can kind of imagine Kubernetes as not only a container orchestration engine, but also like an API standard. So how do I define my APIs around setting up additional services? And let me illustrate just that for the 3 services that I commonly hear that application developers are requesting. So for example, if you want to run Postgres inside a Kubernetes cluster, we like to use the Zalando Postgres operator. And on the left, I'm having here the code, an example of a code that you would need to send to Kubernetes. And this code pretty much defines a PostgreSQL cluster, which is having 2 instances, which has logical backups enabled. It uses Postgres version 13. It has 30 gigabytes of storage. And then lower, I say that this cluster, I mean, each replica of the cluster should use 1 CPU and should be allocated 4 gigabytes of memory. And below, we also set some tolerations, so to make sure that it only runs on specific database nodes and that there is a certain level of isolation between the nodes that are running a application and the nodes that are running a database for better capacity management. And just by writing these rather few lines of code, you're essentially getting for free capacity management. So the database cluster will run on dedicated nodes. Thanks to the features in compliant Kubernetes, you get for free monitoring. You also get for free an audit log. So whenever an application developer wants to connect to the database cluster for, let's say, doing a database migration, or let's say for some ad hoc analytics, you're getting for free an audit log. You know exactly which user has connected at what time to what database cluster. You also get point-in-time recovery. So this is very good for your disaster recovery posture. And the Zalando operator will also take care of primary failover. And it does this by actually reusing the key value store etcd inside Kubernetes in order to make sure that, well, there is exactly one primary inside the Postgres database cluster. And you can do the same thing also for Redis. So there are quite a few good operators out there. We're using one that is from a company called Spot-A-Home. And so if you want to run Redis in a highly available manner, you need to configure it with Sentinels, and you need to have at least 3 replicas. And here is how you would send this piece of code over to Kubernetes in which the Redis operator is being installed. And that would make sure that you have the right capacity management set up, that monitoring is being enabled. So I haven't highlighted it here that well, but you also get a special exporter for Redis that then exports various metrics into Prometheus. And in case of compliant Kubernetes, those are being caught and then sent all the way over to some Grafana dashboards. And you can also configure alerts based on that. And again, you would get high availability for free. And the nice thing is that if, for example, your cluster is configured in a way that it spans data centers, then you no longer need to deal with that complexity on the Redis cluster level, but rather Redis cluster will just naturally spread across data centers. And since Kubernetes offers a private network on top of the infrastructure, it wouldn't really matter to the Redis cluster that it's spread across data centers. It would just work. And then finally, you can do the exact same thing for a RabbitMQ cluster. Again, if you want it to be highly available, you need at least 3 replicas, especially if you want to work with quorum queues, as is recommended. And then again, you would get for free capacity management, monitoring, audit logging, and high availability. So this sounds all really nice and really cool. On the positive side, we found that this way of reasoning about your platform really allows to future-proof your tech stack. So whenever a customer to us comes and says, hey, can you run our application on-prem, or can you run application on another cloud provider, it's no longer a question of if, but it's mostly just like, okay, let's audit your infrastructure and see exactly what you offer. And then depending on that, we need to configure the platform a little bit differently in order to make sure that everything works. And what it really enables you is to eliminate those tedious and error-prone tasks. So I'm not sure how many of you have set up from scratch a replicated Postgres cluster, but there are some steps that you really need to make sure, to make sure that the primary is configured correctly, then make sure that the secondary is correctly finding the primary, make sure that they're in sync, so they're not, that the WAL files can be copied from one to another, and that there is not too much replication lag between them. There are some tedious and error-prone tasks, and just so nice if something automates those things away. And what you obtain at the end of the day is a portable security and compliance. Now, on the downside, our experience shows that you still need the right skills. So just because this code exists out there and we made it available for out there doesn't mean that, well, you can just forget the people. So you still need highly qualified Kubernetes admins that understand the whole thing, and especially if there is an incident, they know exactly what talks to what and what to investigate. But then also you need some service-specific administrators, because although it's pretty easy to configure a RabbitMQ cluster or Postgres cluster thanks to the operator pattern, very small configuration changes might have a huge impact on your security and compliance posture. So you still need the right people to understand all these trade-offs and to explain like how can to decide how can you best fulfill your security and compliance requirements with the tools that you have available. So to sum up, I see a growing need for data sovereignty, and I see that this trend is growing at an alarming rate. So therefore, I suggest everybody to start focusing more and more on on-prem, non-US clouds, and multi-clouds. I have talked to you about how Kubernetes can be used as the platform engine that on one hand allows you to focus on your application, but on the other hand allows you to control your whole tech stack. And I recommend you to check it out and let me know what you think about it. And yes, I'm available via LinkedIn. So in case you have